Petra, and thank you everybody for coming. It's really lovely to see all of you here. I am looking forward to telling you about the science and solutions of climate change. So just first of all, a little bit about myself. As Petra said, I'm a neuropsychologist, I'm not a climate scientist, so why am I up here talking to you? The reason why is that, like Petra and Greg, I've been on my own journey of understanding the climate crisis. Probably for about 10 years or so I've been quite concerned about it, but I think it was really the election for me that was the tipping point that made me go, oh, they're not going to do anything. We need to do something ourselves. And at the same time, there was, a whole lot more information coming out. I've been reading more about the state that the science was at and becoming more and more concerned. And then when there was that point of the election, I thought to myself, okay, I need to do more. And it was then that I found out about Extinction Rebellion, and the thing that really spoke to me from Extinction Rebellion, it was the basis on science, not just the climate science, because that's very clear, and we all know about that now. Well, not all, but the scientists certainly know about that now, but the social science of how to make change. And that's what we're going to talk a little bit about this afternoon. So we are going to do this in 3 sections. So the first bit is to really just go over what is the current state of climate science. And I want to just flag at this point that this does get a little bit heavy going, because if you're not up on the state of climate science, it's pretty rough. So I just want to flag at this point that if at any point you feel like you want to leave the room for a moment and take a little bit of time, please do take care of yourself. We are going to talk about the regenerative culture as part of Extinction Rebellion later on, but it is really important. And also maybe just have a think to yourself now how you might support yourself after this, in the days or weeks after, if you're thinking about this science and thinking, gosh, I didn't realise it was so bad, because that might be the case for some of you. Just have a think about where you might get some support to be able to work through that. So that'll be the first section. Then we'll have a little bit of a break and kind of debrief, shake it off. Then we get into the solution, because I'm going to tell you how bad it is, but then I'm also going to tell you what we can do about it. And there is stuff that we can do about it. There's plenty, and there's a good reason to be hopeful because of that. So then we're going to talk about that. And then for the third section, we'll then have a little bit of a break then as well. For the third section, then we'll give you the option at that point, if you're thinking, okay, that's about as much as I can take in for today, I'm good, I just need to go and sit on that for a bit, you're welcome to leave us at that point. But if you're going the other way and thinking, yeah, sign me up, like Petra at the Sustainability Festival, thinking, bring it on, what can I do? Then you can stay and we'll talk a little bit more about how XR actually works, the working groups and all of the different kind of ways that you can get involved. And so that will be the last section. So you've heard a bit from Greg and Petra and myself about why you're here. I want you to take 1 minute, literally 1 minute, I'm going to time you, you've 30 seconds each, so 1 minute, 30 seconds each to talk to the person next to you and just talk about why did you come here today? What was the reason why you've decided to take time out of your Saturday afternoon? I know I'm going to make it really uncomfortable to talk to people that you don't know. I know people hate this. I promise I won't call people out individually, but I am going to ask you now to just turn to someone next to you. Your time starts now. 30 seconds each. That's 30 seconds. Change over if you haven't already.
Industrial automation.
Okay. Thank you. So, if you didn't know, this is the black-throated finch, I should just point out, which just won Bird of the Year. Very exciting. It is a bird that will very likely go extinct if Adani goes ahead. That's why that bird is up there. Okay, I've got here to start with some quotes from the IPCC. You'll hear me talk about this a little bit this afternoon. The Intergovernmental Panel on Climate Change. It's basically a whole lot of people, all of the best scientists from a range of countries around the world. They get together and they work out, okay, what can we all agree on about the state of climate science? If any of you have done group work before, you'll know how difficult it is for them to all get in a room and agree. And that's why actually what comes out of the IPCC is actually quite conservative, because they've had to agree on what the lowest common denominator is, what they could all agree on. So that's just a flag. I'm going to come back and talk about why that's important throughout. But first of all, I've got Eric Solheim, who says, it's like a deafening, piercing smoke alarm going off in the kitchen. We have to put out the fire. Deborah Roberts is the co-chair of the Impacts Group. It's a line in the sand, and what it says to our species is that this is the moment and we must act now. The next few years are probably the most important in our history. I'm sure all of you in the room would also know about Greta Thunberg, and one of her quotes is, I want you to act as if you would in a crisis. I want you to act as if our house is on fire, because it is. And this is one of the key things that I'm going to talk about. One of the big kind of problems in addressing the climate crisis is that there's so many of us who are really not on board with that and not understanding the state of the crisis. I think this next photo really sums that up. When I first looked at this, I just assumed it was a doctored photograph. It's not. Yeah. Jesus. That's a real photograph. Oh, God. That is a real photograph. And I think it sums up just perfectly what's going on. This is in California. There are raging bushfires. And these guys are just like, carry on. Business as usual. No problems here. Nothing to see. I got a game of golf. And that is the most important thing right now. And look, there's a whole lot of reasons, I think, why that is happening. But I'm going to just take a slight detour and just tell you about a psychological effect that I think is really relevant here. And I'm going to come back to it later on. But it's actually, I think, really quite important in our understanding of what's happening in this situation, or in our understanding of why things are not happening in this situation. And it's called the bystander effect. And so this is some pictures. You can Google this. If you Google the bystander effect and the smoke-filled room experiment. This is an experiment that they did in the 70s, and you can see this on YouTube. And I'll tell you about the experiment, and then I'll tell you why it's important. So the experiment is that what they did is that they got subjects to come in and said, okay, I want you to come in and fill out this bogus questionnaire. So they would get somebody in the first scenario up here, they would get them to come in, and there's just one person there in a room, and they would get them to fill out the questionnaire, and a minute or two in, smoke would start coming in under, fake smoke, but the person didn't know that, smoke would start coming in under the door. And in that condition, generally, you'd see, like, so you can see this video, you see the people there, they're filling out their questionnaire, and you see them go, and then it's an average of about 90 seconds before they hightail it out of there. That's a picture of that person hightailing it out of there. In the second condition, there's one person who's part of the study, and then there's about another 10 people who are in on it. This person doesn't know, but they're all sitting there doing this questionnaire. Only one of them is the experimental subject. The others are in on it. The others know when the smoke comes in, do nothing. That's their job. So this person, same thing, smoke starts coming in under the room. They're doing their questionnaire. They look over at the smoke, and you see them. They look at all the other people in the room doing nothing. They go back to their questionnaire, and they look, and you see them go, really? They keep going. They last 20 minutes. They last till the end of the experiment. They just keep on going. Smoke just keeps pouring into the room, and they just keep on going. Why? Because when we think about threat in our environments, we use a whole lot of information. Right, so you would assume that the biggest piece of information that person is using is the smoke. There is smoke, which means a fire. You would think that would carry a huge amount of weight. But because we are social beings, our brains have evolved to understand social information and to prioritise social information. And so what our brains do is look at, okay, on one hand you've got the smoke, but on the other hand I've got 10 people who are doing nothing. Okay, so they do nothing. And that's, I think, gives you an idea of what's kind of happening now, because on the one hand we've got the scientists saying it's a smoke alarm, you know, it's like a deafening, piercing smoke alarm, but then you've got ScoMo taking a lump of coal into Parliament. ScoMo. And so then, you know, you think, and a whole lot of people who are not aware of this information, just carrying on as business as usual. They're just playing their game of golf. Because although there's that fire in the background, they're looking at everyone else going, okay, well, just carry on, business as usual. So we're going to come back to that at the end, because that's one of the things that we really need to overcome in order to solve the climate crisis. Okay, here's where it starts to get heavy. We're going to talk about the threat. I'm going to tell you about the evidence for climate change. And I'm going to tell you about the evidence about whether or not we are really in a climate and ecological emergency. Spoiler, answer yes. Okay, this is one of my go-to graphs if I need to explain to somebody the nature of global warming. This is a graph from the NASA website. You can very easily find it if you Google NASA and climate change. And this is a graph that looks at carbon dioxide level over here, and then years before today. Okay, so this is 800,000 years ago. And you can see there's a natural cycle of carbon in our atmosphere. What you can also see is that once it gets to here, that's 1950, and that's now. So it's very, very clear that this is different now. This is not part of the natural cycle. Carbon dioxide is one of the greenhouse gases. It's probably the most common one. It's not the most potent one. That would be methane. Actually, there's probably a couple of others that are less common that are more potent. But essentially what they do is that they form a blanket over our atmosphere. And so because of that blanket, it keeps the heat in and it makes things warmer. This is a graph of temperature. So again, on the left here we've got temperature, and this is 0 AD, and then 4,000 years ago, so this is 16,000 years minus AD. You can see temperature here. This is the Industrial Revolution. This is where we are now, about 1.1 degrees warmer. This is where we are predicted to be by 2045 under the current policies, and this is where we're predicted to be by the end of the century. So again, there's quite a strong correlation between the greenhouse gases in the atmosphere and temperature, and that's been borne out now over 30 years. There's very strong research. It's really just not debated at all at this point. That's very, very clear. But what does all of that mean? What does it mean if we have warming? If we have global warming? So we know that what it means is that there are a whole lot of effects of that global warming, and then I'll talk a little bit as well about the ecological factors too. But plenty of evidence now that Australia, for example, is getting warmer. So there's hottest days ever, every year or so at this point. July was the hottest month ever recorded on record. There was a day recently where it was the first day ever recorded on record where there was no rain across the whole of Australia. We also know that glaciers are disappearing, thinking globally as well. The ice is melting, glaciers are disappearing. And that in heat waves, people are dying. There's only so much that we can take in terms of living in a heated atmosphere. So we often think about the bushfire threat, and of course that is a huge threat that there's plenty of people facing across Australia at the moment. But when there's heat waves, actually more people die from the heat than the fires when there's a heat wave. So that's something pretty serious we need to consider. And then sea levels are rising. Ice, glaciers are melting, sea levels rise, and so then there's a whole lot of effects that happen as a result of that. And I think sometimes when I hear people talking about the sea levels rising, it's as if, oh well, you know, okay, that country will just go underwater, but they can just kind of go somewhere else. They just talk about it as if there'll just be a new beach, it'll be fine. But that's not the case. And look, this is an example of, just Aster Ali, it's referred to. This is Bangladesh. This red area is all very heavy in agriculture. Bangladesh is very low lying, so that there will be sea levels are rising there now. But it's not just about the sea level rises. Before you get that new beach or new water that comes up, you have the salt that comes in underneath, the salination of the land. So all of this area here is land that should be making food, but that is very soon, and certainly on the way already, not going to be able to make food. So then you have millions of people who are there on the land who will starve. Now that's the climate side of it, but then you get to the climate justice side of it, which is going to be a huge part of what I'm going to talk about today, because what we have here is the wall between India and Bangladesh. India have already built a wall, Trump style, and it is manned by soldiers with guns, and they are not going to let anyone from Bangladesh in. I know, right? It is really scary. And I showed you a picture just before of that was this one in the Indian heat waves a year or two ago, and there plenty of people died in those heat waves. And when they were handing out water and supplies for people, they were doing that based on caste. Climate justice. Climate justice is about the fact that the people who are going to be most impacted by climate change are the people who've done the absolute least to actually cause it. And the people who are the people who don't have the means to do anything about it. Okay, we know that bushfires are getting more intense, and there's plenty of evidence of that, right? At the moment there's bushfires raging. We're in November, and they are raging in areas that haven't previously been affected by bushfires before. And there's plenty of evidence to suggest that it's climate change that is resulting in that. There's I won't go into that, but you can Google that really easily. There's a couple of great articles that explain those links. This is a picture of a tree that was burnt in Tasmania, in forests there that just haven't burnt in 1,000 years. And these events are happening more frequently. In fact, there was a great quote by I think it was Tony Abbott saying, "Oh no, there's nothing to do with the bushfires. We've had bushfires in this year and this year and this year and this year and this year." And someone kind of looked at it and went, "Yeah, but can you see the pattern there? It was like this year and this year, this year and this year, this year and this year, this year, this year, this year, this year." Like it's clearly happening more frequently. We know that parts of regional New South Wales are set to run out of water by November. This November that we're in now. I tried to research this and find that it looks like they haven't run out of water yet, the ones that they're talking about here, but they're under severe water restrictions. Basically kind of counting down to day zero, where they will potentially run out of water. Of course, in plenty of these places, what you'll find is that there are coal mines nearby, and that the water is being brought in by trucks and going straight to the coal mines. And there was a quote by one local mayor for one of these towns that was saying, "Yeah, we're looking into getting some water in for the locals," but of course they've gone for the coal mine very first. So food and water shortages contribute to mass migration, because if you are part of millions and millions of people who don't have food and don't have water, you are very unlikely to just stay where you are. You are going to try and get help. You are going to move somewhere else. And if you know anything about Australia's immigration policy and our track record with refugees, you can just imagine what that's going to look like for us here. And again, thinking of Bangladesh and India across the world as well. These are some figures from the World Bank that said that 800 million people at risk from rising sea levels and storm surges, and 140 million people will move between their countries' borders by 2050, 30 years away. Now, that's the warming, but there is also an ecological emergency. So they're related, but they are kind of qualitatively different as well. So this is a picture of a healthy mangrove system up in Queensland. This is what it looks like when it was healthy. This is a few years ago. And this is what it looks like now after a heat wave caused a massive kind of warming within the ocean. This is us. This is Australia. This is what it looks like right now. This is what a healthy reef looks like. And this is what part of our Great Barrier Reef looks like now after underwater heat waves a few years ago caused severe bleaching, resulting in the death of a third of hard coral. And the underwater reefs, you know, again, you hear people talking about this and you think, okay, they talk about it as if, well, that's a shame, you know, Great Barrier Reef, it's a beautiful thing, it's a shame. But the fact is that a whole lot of that coral is actually making out oxygen. So it's not just a shame, it's a crisis. An insect apocalypse. Now, I don't know about you, but when I first saw this slide, I thought to myself, apocalypse, really? That seems harsh. That seems pretty severe. And then I Googled it and found that there are our best ecologists are using this term because, for example, 40% of the 1 million known species of insect are facing extinction. And I spoke to someone at one of the XR events a little while back, and he said to me, the reason that I'm here at this XR event is that I'm a truck driver and I drive my truck between Sydney and Melbourne. And I'm here because 30 years ago, I had to stop every half an hour, and now I can drive all the way straight. And I was like, what are you talking about? And he said, because 30 years ago, I had to stop every half an hour to get the bugs off my windscreen. And now I can drive the entire way. And there's a couple here and there, and that's it. And that fits with what we know about the research. And again, that's a shame, right? That insects are dying. It's not just a shame. These insects are pollinating our food. It's a crisis. So much so that plenty of people are calling this the 6th mass extinction. So there have been 5 mass extinctions in Earth's history that are, from what we understand, from natural causes. Possibly they might have been from warming. We don't know. But what we do know is that Australia, for example, is leading the world in rates of extinction. For example, this fellow here is the leadbeater possum is likely to become extinct within 20 years. And there was the first mammal to be lost definitely to climate change was just recently. It was an Australian animal. And again, it's a shame, right, that animals are dying, but it's also all of these animals form part of a very complicated ecosystem. And when one thing dies, it has effects on everything else. And what happens is that you start to get to the point where things snowball. And we're getting to the point where it's very difficult for our scientists now to work out what is actually going to happen, because it's so hard to model the interaction effects of all of these things happening at one time. So we have all of that science on the one hand, and on the other hand, you have the Paris Agreement. So there are plenty of people, I think, out there who think it's okay, we've got the Paris Agreement. We've all sat down in a room, our leaders have agreed. There's a couple of problems with that. One, people like Trump, and in fact, Trump has just pulled out of the Paris Agreement, but even our Prime Minister is saying, yeah, we're on track. It's a blatant lie. We are nowhere near on track for the Paris Agreement. That's one problem. The other problem is that I talked before about the fact that the IPCC are conservative in their estimates because they have to go with what everybody has 100% agreed on, and it's very difficult to agree on things when you are modelling worst case scenarios. But actually, now that we've got a little bit more data, there's some evidence to suggest that because of feedback loops, that actually the Paris Agreement is going to take us at least to a world that is 3 degrees hotter, and quite possibly 5 degrees, which doesn't sound like a lot if you're thinking about just one day in Melbourne. But when you're talking about 5 degrees of averages across the whole world, what 5 degrees of warming would mean, well, let me tell you about this. This is where it starts getting really heavy. My apologies. Before I talk about that, I do need to just give you a little bit of evidence about the feedback loops and the tipping points, because that's why the IPCC stuff is so conservative, because they haven't taken that into account, because it's much more difficult to model. And so there's a whole lot of different ones, but I'm just going to explain two of them for you to kind of give you the idea. So one of them is about methane venting in the Arctic. I spoke about methane before. It's a very potent greenhouse gas, much more potent than carbon dioxide. There's a whole lot of methane that sits within the permafrost in the Arctic. Permafrost, as the name would suggest, is supposed to be permanent frost, but it's melting. And so what happens is that as it melts, that methane is released into the atmosphere, the world becomes warmer, the permafrost melts. The warm becomes warmer, the permafrost melts. And so you have this cycle. And there's some recent research that looks at methane, and it is astounding to look at what's happening. There are some researchers looking out there, and you can see there are places where it's melting and the methane is just bubbling out. It's really quite scary. So that's one, and the other one is the feedback loop that happens when you have melting ice and then a whole lot of ocean. So if you've ever worn a black t-shirt on a hot day, you'll understand the feedback loop that I'm about to tell you about. So usually in the Arctic, in fact I'll show you this on here, this is a picture of, this is what the Arctic ice looked like in 1984. Keep watching and it's going to show you what it looks like along the way now. So you can imagine if you've got the Arctic, you've got a whole lot of white ice and a little bit of dark ocean. So the white ice is going to reflect, the dark ocean is going to absorb the heat. The less ice you have, the more dark ocean. So the less white t-shirts, the more black t-shirts that are going to soak up all of that warming. As the water gets warmer, the ice melts. So you have this feedback tipping point. So you can see very clearly here that the ice is melting, and this is one of the feedback loops that is tipping things over for us now. So that's what it looks like in 2016. And in fact, Alaska's sea ice has completely melted. Now, for the first time in recorded history, Alaska doesn't have any sea ice. Now this is a quote from a climate researcher and a graph, which I'll talk to in a second. The quote here is that the current melting rate of our ice is equivalent to what the model predicts for 2070, using the most pessimistic model. And this is why our Paris Agreement and our IPCC has sort of lulled us a little bit into a false sense of security. Even though the IPCC was probably bad enough as it was, it's actually looking a whole lot worse than that, because this is what they've suggested things should look like. This line is what they kind of modelled. And then the grey area around that is the standard error of measurement. So whenever you're modelling something in science, it's an inexact science, it's an inexact art, so there needs to be a little bit of, we reckon our best guess is around here, but 90% chance that it'll be between here and here. That's what it is now. It is much, much worse than what they have modelled.
Excuse me, by the model you mean the IPCC model?
Yeah, yeah. Yeah, and please do ask me questions along the way if you want to clarify something. It's too hard to hold it in your working memory for all of that time. And so that's just two, but there are tipping points that we are close to or past in all of these places across the globe. And I'm not going to go into these, but there's a whole lot of this research that is available in, Petra talked about Jane Morton's giving a talk, one of the founders of XR in VIC, and she's written a great book called Don't Mention the Emergency, and there's lots of those kind of references in that. I can also provide references for everything. Oh look, she's so organised, she's got some copies at the back. And I can also provide references for all of the graphs. All of the information I've got on here has got a scientific reference to back it up, which I should have mentioned at the start. So the reality is that we are running out of time, and we are close to now tipping points. And so if you picture this dude here coming along in his kayak, getting towards the end of a waterfall. The closer you get to that waterfall, the harder it is to stop him. It's going to take a huge effort to stop him at this point. But if he tips over, there is no chance. He's done. He just has to go down because the forces are just too high. And what the scientists are telling us now is that we are getting really close to that tipping point. In fact, as far as I'm aware, the best research that we've got suggests that we have about 8 years to keep on burning carbon at the rate that we're burning it before we would get to a point where once we cross that, it doesn't matter if we rein it back to zero. The damage is done. We are too late. We're over the tipping point. And that's what this graph shows you here. So we are at this point here. The Anthropocene is the period of the sort of epoch of time where humans have been on the Earth. Because we actually haven't been, the Earth has been around a long time. We haven't actually been here that long in the big scheme of things. But we are sort of at this point here, and scientists are saying, look, if once we kind of get to here, you're down here towards hothouse Earth, which is basically a world that is so warm that it can't sustain human life form. We are at the point now where we can head over this way, and it will still be too warm. It will still be a bit warmer. We'll be still facing, bushfires and a whole lot of other things, but we'll be able to sustain human civilization at some level. What it's going to look like is hard to know. So this is Professor Hans-Joachim Schellhuber, who is a recipient of a Nobel Prize. So a pretty clever guy, and his quote here is that climate change is now reaching the end game, where very soon humanity must choose between taking unprecedented action or accepting that it has been left too late and bear the consequences. This is our eminent climate scientist telling us this. And what we know is, at the moment, we're on track for possibly 5 degrees of warming by the end of the century. We know that at 4 degrees, there's no certainty that we'll be able to adapt to that as a civilization. The best estimates that we've got is that, at best, we could only be supporting a world with 1 billion people in it. So I don't know about you guys, but I've got a 3.5-year-old daughter. At the end of the century, she'll be about 84. And that would mean that throughout her lifetime, if we even get to that point, remember this is the best case scenario, that she will live in a world where 6.5 billion people die. I know. It's really, really frightening. I am going to tell you what we can do. Stay with me. Hang in there. I know it's bad, but I am going to tell you how we can turn the ship around. So, before I tell you that, I have to tell you the other side. That was the best case scenario. This is the worst case scenario, is that are we looking here at the end of civilization? And again, I know when I first started reading this stuff, my first thought was like, really? Really? Is it that bad? No one's doing anything about it. Is it really that bad? These are our best researchers. And in fact, a couple of researchers in Melbourne, so there was from the Breakthrough Institute in Melbourne, they did some modelling to look at what is the worst case scenario. Because on the one hand, you've got the IPCC with these conservative estimates, but what we're looking at the moment is, for example, if we only kind of reduce things down, if we only kind of reduce things down a certain amount, the scientists are saying, well, by by the end of the century, maybe we'll have a 50-50 kind of chance. I don't know about you, but if I was getting on a plane that said 50-50 chance it'll get there, 50-50 it's going to go down in the ocean, I would not be getting on. So we do need to know what are the worst case scenarios, because it could be those. You know, we don't know what it's going to look like. It could be okay. 1 billion people could survive. It could be the worst case scenario. So they looked at what those scenarios might look like. And keep in mind, this was written by a climate scientist, David Spratt, and also a former fossil fuel executive in Dunlop, and the former chief of the Australian Defence Force, Chris Barry, wrote the foreword. So they're not a bunch of raging lefties, these people. These are seriously, probably on the kind of conservative side of things. But what they found is, I've got 2 slides that have got a big quote on them, but I thought that this was important enough to show you the quote. So when they looked at that, what's the kind of worst case scenario, and this is, by the way, 2050 that they are modelling for. They've said most regions in the world see a significant drop in food production and increasing numbers of extreme weather events, including heat waves, floods and storms. Food production is inadequate to feed the global population, and food prices skyrocket as a consequence of a 1/5 decline in crop yields, a decline in the nutrition content of food crops, a catastrophic decline in insect populations, desertification, monsoon failure and chronic water shortages, and conditions too hot for human habitation in significant food growing regions. So even for 2 degrees of warming, more than 1 billion people may need to be relocated due to sea level rise. And in the high-end scenarios, the scale of disruption is beyond our capacity to model, with a high likelihood of human civilization coming to an end. This is their quote. This group of not raging lefties. So this is another way of kind of showing that. This is some of the modelling that they look at. So here we've got temperature, increase in average temperature, and here we've got probability. And this level is saying, okay, if we go hard now, then we've got a chance here of staying below, 50% chance of staying below 1.5 degrees, which of course we're at 1.1 and we're seeing these bushfires. So this is not to say this is totally safe territory, it's just safer. That's if we do some extreme action now. This is if we do slow to moderate energy intensity reductions. Are these two ones here, slow, moderate. This is slow, and this is looking at when climate feedback loops are considered. So this is what we are on right now. And what this means, this is probability, this is temperature, and these are the risk categories that they have classified at each temperature. So what this graph is saying is that if we stay where we're on now, this is the middle of the probability, we have a 50% chance of existential threat. By the way, when they were doing this, previously they'd only modelled up to catastrophic. They had to add in a new risk category in order to do this. Existential threat, in case it's not 100% clear, means threat of human extinction. So can I just underline that point? Again, I am going to tell you what we can do about this, but just to be really clear that the science at this point in time tells us that if we don't do anything, then we are on track for a 50% chance of human extinction. We are on that plane with a 50% chance right now. We're on. So that's what you get from the science on the one hand, and on the other hand, you've got this guy, Bolsonaro in Brazil, this guy. We've got some big roads that they're building. We've got some more big roads. We've got big airport that we're thinking about building. We've got Adani and what's his name, Clive Palmer, wanting to build another 6 coal mines after that, taking up all our water and just spewing emissions into our atmosphere. Honestly, it beggars belief. What the hell are they doing? Well, this is what they're doing. They're having dinner with the mining magnates. This is what they are doing, and this is the massive problem that we have here. This is the one of the biggest reasons about why our leaders are not doing anything about this, is because there is evidence now that the coal companies, years ago when they found out about this, ran a scare campaign. So I talked before about how there was that line in the graph and there was the standard error of measurement around that. With any science, you find that there is always a standard error of what you are measuring. They used that and tried to flip it and got people to think that, no, it's uncertain. We don't know. We don't actually know. No, it's all uncertain. There is, of course, uncertainty along with the specific numbers, but the predictions were clear, and they ran a specific campaign to make sure that people didn't act on that. And then at the moment, you have, for example, our Liberal Party at the moment are hugely funded by big coal. And if you have a look, Michael West did a great documentary for Greenpeace called Dirty Coal, and it shows you really clearly, it just lays out all the people who are currently in the Liberal Party and what coal company they came from, where the donations came from. And I've got to say, I knew about this, I knew this was a thing, but when I watched this, it's about a 10-minute, I think, documentary, my jaw was hanging on the ground by the end of it. I just could not believe that this could be legal, that this could be allowed to happen. I was just gobsmacked. Are you serious?
it's worth adding to that the influence on at least parts of the Labor Party by mining unions.
Yes.
That it comes from another direction, but it's also an important factor.
Yes, yes, absolutely. I shouldn't single out just the Liberal Party. So you're absolutely right. It's within our two big major parties. Yeah, it's a very good point. So there's a great quote by George Monbiot, which I'm going to get wrong, but it goes somewhere along the lines. So he's a journalist who's been writing about this for a very long time from England. And he says that something along the lines of that Big Coal's master stroke was pinning the climate crisis on you and me. Because in reality, we've got 100 companies that actually are responsible for 71% of the world's global greenhouse gas emissions. And this is why, when we talk about, okay, well, I've got, my car and I've got, I use my keep cup and I try and compost and, I try not to use the car, I try and catch public transport, all of these things, they're great and they will all add up, sure. They will go some way, but they are never, ever, ever going to solve the problem because we have got 100 companies. And who's letting those companies go ahead? The governments. Why? Because they're funding them. So this is what we have to do, yeah.
I have a bit of reading background,
Yeah.
but really at the basis of this, our politicians must not understand the science. You couldn't make those decisions if you had children and grandchildren, if you understood the science.
I think they want to be one. I think they want to be part of the 1 billion. I honestly think people like Scott Morrison, he believes in the rapture, which says that only some of us will be saved, and they think that they're going to be the ones who are the 1 billion. So it's okay.
I think,
Can I say something?
Yeah.
I interviewed someone the other day. Lived in Scott Morrison's electorate, and he briefed him 6 years ago. He said he studied science, environmental science. Scott Morrison, I thought he was an advertising man, in business only. He said, no, he studied science, climate science. So there's no question about it.
look, I think that it's a really important question that you raise, a really important point, and I'm going to touch on it very briefly, but it's a whole other talk. But just very briefly, I think from a psychological and a neuropsychological point of view, that actually there's a whole lot of stuff that we process subconsciously. When I think of subconsciously, I'm thinking of the subcortical part of the brain, the very deep part of your brain that is below your conscious awareness. And part of that part of the brain, a big part of what it does is your values, your belief system, all of the kind of unconscious decisions that you make day to day happen subcortically in that subconscious part of your brain. I don't think that he doesn't understand the science. I think that he's got that on one hand. On the other hand, he's handcuffed to the coal companies, and so there's that in that sort of part of the brain that's very, very deep is just blanketing him, and he's just in very, very deep denial. And I think his brain is actually preventing him from understanding the science and really kind of integrating it. That's my kind of take on it, because I mean, if I don't think that, I think, what the hell, is he evil? Like, is he actually? Are they actually just evil? It's
sort
hard
of like
to.
a subconscious fear of another extinction, which is that their funding source,
Yeah.
losing their funding
Yeah.
source. So that's
It's
the
very
immediate
short-term
threat.
focus. Yeah.
Excuse me, can I ask a question,
Yeah.
please? Before we get too much in what we are not doing here, it seems to me you should be telling us what is being done in Europe, for example, which is far ahead of us in looking after their emissions. Could you give us a bit of a rundown on what's being done in other parts of the world?
They are certainly far ahead of us.
That
That's
we're
true.
not doing?
Yeah,
What are they doing?
Yeah, it's true. So look, there's a whole lot of, for example, in Germany, they've just shut down all of their coal and going based on renewable energy. So there's a whole lot of kind of renewable energy stuff that's happening. And there's also a lot of science that's kind of looking at drawdown, which is how can we get rid of the carbon that is in the atmosphere and draw it down. And of course, there's a very, very technical, scientific way of doing that, which is planting a tree. So there's that. First thing, of course, would be to stop cutting down the big trees that are there as well. But certainly there is the kind of, the technology is available to be able to deal with this. And I'm not going to spend too much time talking about all the different kind of technology. And the reason why is that what we have to, it's not a problem of technology at this point in time, it's a problem in the political will to use that technology. And that's what we can have an influence on, is being able to influence the political will. So I've just got a few more slides before we have a bit of a break. So look, when I kind of got to the point of really getting into the science and realising just how bad it was, I did think maybe I should just go and live off the grid and just take my kids and make sure that they can be sustainable and learn to make food, you know, where we are, and just like stick my head in the sand, because oh my God, it's so full on. I thought about it, I won't lie, I thought long and hard about whether that's what I should do. But the thing is, we can have an influence, and there are times where I have felt very much that there is no hope, and I think, you know, from seeing some of this stuff you can see how you could get there. But actually, you know, there's this quote that hope dies, action begins, and when I first saw that, I thought, what do you mean? How can you be motivated for action without that hope? But I think I kind of understand that now, because I've been on this journey of understanding the severity of the climate crisis, and getting myself to a point where I've really spent a whole lot of time grieving for the future that I thought I had, and the future that I thought that my children would have. Because even in the best case scenarios, things are looking like they're going to be pretty different to what I thought. But what I actually got to was realising just how damned lucky and privileged I have been to this point, that I can even spend my time talking about climate activism, and that I'm not living in Bangladesh.
Yeah.
You know? And so what I have the point that I have got to is that, okay, we don't know what is going to happen, but there is a way that we can try and turn this ship around. There is an evidence-based way, and I'm going to tell you about that next. And I have come to the point where I think, okay, I'm just going to focus on living by my values, and living by knowing that I've done absolutely everything that I can. Because I think if I was standing there and there was a car with a whole bunch of people just slowly pushing this car off the edge of a cliff, and I've got one choice for how to live my life, am I going to be one of the people behind the car pushing? Or am I going to be one of the people at the front trying to stop it, even if I don't know whether that car's going to go over the cliff or not? I want to live my life being one of the people who's trying to stop it. So we're going to take a short break now to grab a cup of tea, and please debrief, shake it out, talk to the people next to you. Just a quick 5 to 10 minute break. So we'll be back here at, say, 10 past. And then stay with me, because I'm going to tell you how we can turn this around.